Vijay Prithir.
I am Krishnan.
And I'm Malani.
We are from 9th grade. We are going to explain about biology and chemistry. Let me start with biology. Today we are going to dive into an exciting topic and interesting topic in biology. It's nothing but plant tissues. Now my friend Valan will carry on.
So, anybody have idea what can be a tissue? Like, what is tissue? Correct. Can perform a specific function. So, there are two types of tissue. One is plant tissue and animal tissue. In plant tissue, there are also two types, which is mesosomatic tissue and permanent tissue. Mesosomatic tissue can be classified into three types. Mesosomatic tissues, also known as growing tissue, which actively divide, which helps in growth. Can be classified into three types. One is apical meristem, intercalary meristem, and lateral meristem. Apical meristem is present in growing tips of root system and shoot system, which helps in growth and is involved in primary growth of plant. Intercalary meristem is plant and present in epinode region of plant. And lateral meristem is present in lateral stage of plant. They are present in higher plants like trees. That's all. Know about permanent tissue.
In permanent tissues, I am going to explain about supportive tissues. Supportive tissues are supportive in nature. In supportive tissues, there are mainly of three types: parenchyma, collenchyma, and sclerenchyma. Parenchyma are made up of living cells, and their cell wall is made up of hemicellulose and cellulose. Parenchyma are of three types. They are parenchyma, prosenchyma, and chlorenchyma. In parenchyma, the cells are made up of large air cavities in which they provide buoyancy force to the aquatic plants called as hydrogen. This makes the plants float in the water. Next, I am going to explain about prosenchyma. Prosenchyma is also known as storage parenchyma, in which its main function is to store food particles. Next, I am going to explain about chlorenchyma. As the name suggests, these cells have chloroplast present in them. Chloroplasts are mainly involved in photosynthesis. So, chlorenchyma takes part in photosynthesis. Next, I am going to explain about collenchyma. Collenchyma are made up of living cells in which the corners of the cell wall are irregularly thickened with the deposition of pectin. This makes the plants flexible and provides them elasticity without breaking. This also provides mechanical support to the plants. Next, I am going to explain about sclerenchyma. Sclerenchyma are dead tissues in which they have no cytoplasm present in them. The cell wall is irregularly thickened with the deposition of lignin. Their main function is to provide mechanical support to the plant. They are of two types, sclerates and fibers. Now my friend Vijay is going to explain about complex tissues.
Complex tissues is of two types, xylem and phloem. Xylem has four elements, which is tracheids, vessels, xylem parenchyma, and xylem fiber. Tracheids are long, elongated, angular dead cells which is used for transportation of water from root to other parts of the plant. And vessels are advanced elements which is present in angiosperms, placed one above the other for the efficient conduction of water and dissolved minerals. And xylem parenchyma is made up of storage parenchyma cells, which is used for storage of food which is as starch. And xylem fiber provides mechanical support to the plant. And phloem also has four elements, which is seed cell, companion cell, and phloem parenchyma and phloem sclerenchyma. Seed tubes are slender tube-like structures, and they do not have cytoplasm in maturity. And companion cells have dense cytoplasm and a prominent nuclei. Seed tubes and companion cell is known as sister cells because they originate from single cell. And phloem parenchyma is also used for the storage of food, and phloem sclerenchyma also provides mechanical support to the plant. And in xylem, except xylem parenchyma, others all are dead. In xylem sclerenchyma, in phloem, except phloem.
Now we are done with biology and we are going to move with physics. In physics, we are going to see about force and Newton's law of motion. Now I invite Krishnan to let us know about Newton's first law of motion.
Of motion. Now I am going to explain about first law of motion, in which the first law denotes that an object in rest or motion remains in rest or motion unless or until an external force is applied to it. Law of inertia is also known as Newton's first law of motion. Now there are three types of inertia: inertia of rest, inertia of motion, and inertia of direction. Inertia of rest. The tendency of a body to oppose its change in state of rest to motion is called inertia of rest. For example, now there is a cylindrical tube and there is a wooden plate on the cylindrical tube. I have a metal coin on the wooden plate, and may I have a volunteer please? The wooden plate with high velocity. The wooden plate has been hit and it falls down, but the coin inside it has fallen down. This is due to inertia of rest. Next, I am going to explain about inertia of motion. The tendency of a body to oppose its change in state of motion to rest is called inertia of motion. For example, here I have a suspended string attached to a ball, and when I compress it and release it, the ball moves upward while the cone stays in position. This is due to inertia of motion. There is also another example in which many of you know comedian Vadivel, in which he will be traveling in a bus and he will not be holding the handle, and his friend would tell that எங்க அண்ணா பாரு ராஜ பரம்பரை கம்பி எல்லாம் பிடிக்க மாட்டாரு. Then driver will see backwards and apply sudden brake. Vadivel will go forward, break the glass and fell out of the bus. This is due to inertia of motion. Next, inertia of direction. Inertia of direction states that the tendency of a body to oppose its change in direction is called inertia of direction. For example, if you are traveling in a moving bus and when the driver takes a sudden right turn, you feel a leftward jerk. This is due to inertia of direction. Now my friend Vijay is going to explain about Newton's second law of motion.
It says that the force is directly proportional to the rate of change of momentum. Now I am going to introduce a new friend to physics, which is nothing but momentum. Everyone say hi to momentum. Momentum is represented by B bar. Now I am going to derive an equation. Using the second law, which is nothing but force is equals to mass into acceleration. Let us consider a mass m which is moving with the initial velocity v. By applying force, its initial velocity changes to final velocity with a time interval of t, which is represented in this diagram. So first we need to find the rate of change of momentum. To find the momentum, we need to find the change in momentum. For that, we should subtract final momentum minus initial momentum. As the formula for momentum is equals to mass into velocity, the final velocity is v. So the final momentum should be mv, and the initial velocity is equals to u. So the initial momentum should be mu. Change in momentum is final momentum minus initial momentum. As the value of final momentum is equals to mv and initial momentum is mu, mv minus mu. In this both terms, m is common, so when I take m out, it will become m into v minus u. As per the Newton's second law of motion, the rate of change of momentum is directly proportional to the applied force. So F is directly proportional to delta V by T. So the value of delta V is equals to m into V minus U by T. M into V minus U. So F is directly proportional to m into V minus U by T. And the formula for acceleration equals to V minus U by T. F is directly proportional to ma. To remove the proportionality, we need to include a constant. So F is equals to Kma. In this situation, the value of K is equals to 1. So the formula for force is F is equals to ma. Now my friend Balan will state what is Newton's third law of motion.
Newton states that for every action there is an equal opposite reaction. And you know, volunteer, hope you can see the picture. He's jumping from a boat to the shore. And he moves to the forward direction while the boat moves in backward direction. This states the law of motion. What do you think will it happen when James is jumping from a ship to a shore? Will the boat move backward or remain at the same place? This is less than the ship's mass. I got 4 topics to up. Is this? The second example is when you throw the ball at a wall, it comes back to you with the same velocity. This states the third law of motion. For every action is equal to the opposite reaction. So some other topics I have to cover. So spring force is the disturbing capability of a strength. Here you can see the spring, and if you press this, it provides a force on the opposite direction. This is spring force. Normal reaction, if you take a mass, normal reaction always acts perpendicular to this mass. So normal reaction, mass of this object acts downward due to gravity, which is mg, and normal reaction N acts perpendicular to upward direction. So here N is equal to mg, so the object remains at same position. And tension, if you take a string, if you pull it on the both sides, it creates a stiffness. So tension can be defined as stiffness in a stretched string. Now invite.
Now we are going to see about FBD. FBD is nothing but free body diagram. There are 5 steps for free body diagram. The first step is to identify the system. The second step is to isolate the object from the system. The third step is to find the number of forces acting on the object. The fourth step is to use the Newton's second law of motion, that is F is equal to ma. And the fifth step is to find the acceleration and other physical components acting on the body. Now my friend Vijay will continue.
Two bodies of masses m1 and m2 are placed in a frictionless surface. Find the acceleration of the system and contact force between m1 and m2 when the force F is exerted on m1. First we need to draw the diagram for this. When you apply the force on m1, which is F, the whole body moves in the forward direction. And also the m2 exerts some force on m1, which is nothing but n12. And also the m1 also exerts some force on m2, which is n21. So next we should isolate the object from the system. First we should find the FBD for m1. Next we should find the number of forces acting on m1, which is F, and the opposing force of M2 on M1, which is N12. So next we should identify the net force acting on the object, which is F minus. And when we apply the Newton's second law of motion in this, which is F is equals to ma, so F minus N12 is equals to M1a. So,
Now let us consider the mass M2 and the force acting by M1 on M2 is the only force acting on M2. So it is N12. Only N12 is acting on M2. So there is also mg, that is the weight of the object that is acting downwards, and normal reaction, that is weight acting upwards. As Valan said, mg is equal to n, they both get cancelled. So the only force acting on m2 is n12. Now let us form the equation. Since n12 is the only force, n12 is equal to mass into acceleration. Now find the acceleration of the total system. For finding the acceleration of the total system, we want to add both the equation 1 and equation 2. Let us consider that F minus N21 is equal to M1A is equation 1 and N12 is equal to M2A is equation 2. When we add, first we need to add the LHS, that is F minus N21 plus N12 is equal to, now we need to add the terms in the RHS, that is M1A plus M2A. Here minus N21 and plus N12 gets cancelled. But you may wonder how they get cancelled. The force exerted by mass 1 on mass 2 is equal to the force exerted by mass 2 on mass 1. So they get cancelled. So force F is equal to M1A plus M2A. Here M is common in both the terms. A is common in both the terms. So we get F is equal to M1 plus M2 into A. We need to find only the acceleration of the system. So I am bringing M1 plus M2 to the LHS. So we get force by M1 plus M2 is equal to acceleration. Here always in all the cases acceleration of the system is force divided by the total mass. Now my friend Valan.
Equation 2, normal reaction N2 is equal to M2A. So as Crispin found it, F by sum of masses is equal to A. So I'm going to substitute A values is equal to F by M1 plus M2. Reaction becomes normal reaction N12 is equal to M2 into force by sum of masses. I'll give it to him.
I hope you enjoyed our presentation and learned something new. Thank you.